Four push button switches.
Memory and I was pretty much the same thing as we did in like 8, but there are just a few differences. First of all, the 8-bit, the address is coming in from the 8-bit write bus, and it's going into this 193 chips. And well, like Ben said earlier, the diagram we had at the back, the meDEWsa project diagram of Lab 5, wanted something that like this, and we started off with that, but then we found out that the selection of Marlo and Maha and Marlo will be coming in from the decoder, and also address 1 and address 2, address plus 1 and address minus 1 here, that's does the counting, the selection, counting up and counting down, will be coming in from the decoder too.
So we're going to do a countdown from the decoder?
No.
I mean, you certainly can. I don't know when you'd need to.
That'd be good to do subtraction. That's why we were getting the 15. Do we have a test to make sure? Right now, we've decided to latch the pipeline word and do read select in the same phase of the clock. For the reason being that before, with our read select, we were only reading what was coming out of main memory in 1/8 of our clock phase. So what happened was on the positive edge from Q3 to Q0, we'd click our clock, and it would read out of memory, and then it would not. It wouldn't hold it. So we've changed our clock phase to we're going to move read to the same phase as latch, so that there's 7/8 of the clock cycle now where it is now reading from memory. And we've gotten rid of the inversion of that clock phase, which, because we haven't found any purpose for the enable ALU function select clock phase. Yeah. So that's where we're at right now at the clock phase. And once we get that passed, we'll be able to test the later phases of it. Logically, that makes sense that you would load MPC and increment it before you latch the next address into the MUX register. So, yeah.
I need a bunch of those, like everyone doing some stupid expression. You get to see me having trouble with this wire.
Alright. Hey, I'm Zach Retzloff, and myself and Kevin Pratt worked on Scratchpad memory. Okay. These are 4x4 register file tri-state chips, and we're using them for AC and BR, high and low. You can use just 2 chips for that because of the 4x4 means they hold 4 4-bit words each. And you select which, on each chip, you select which of the 4 words you're writing to or reading from at the time. And down here is the gate logic to select which of those 4-bit words you're selecting at that point in time, and whether or not the chip is tri-stated. And yeah, probably, I don't know. These down here are up-down counters used for the high and low 4-bit words of PC low and PC high and low, and SP high and low. And these up here are tri-state buffers. Should probably get the numbers on those chips. Should I?
270s.
Okay, 270s, 193s down here. Oh, I memorized those. Sweet. And the read and write decoders are 154s. Yeah, that's here and here. And those are 160. I don't guess on that.
370.
Or no, 670. Sorry, 670. All right. Yeah, and I guess the up-down counters and the buffers are tri-state buffers are pretty self-explanatory. They have 4-bit inputs each for the counters, and then those go all 8 bits to the tri-state buffers, and you just turn these buffers on and off with the read decoder, and you load bits into the up-down counters with the write decoder, and that's pretty much it.
Okay, anyways.
Alright,
that's
back to the discussion.
And if you look, these 4 chips right here form the MUX. These 2 chips right here, that's the MPC. This is mReturn. So here we have our EPROMs. I've forgotten the actual name for this chip. Choma, do you remember the name for this chip? That's mReturn. What's this one?
That's
It's the MUX register.
MUX register. Okay. So here's our pipeline register, these 4, and these are merely
3.
used for
3.
yeah, 3. Sorry,
And that's just the none.
that's also used for gate logic as well as these 2. And you see how we labeled all of our outputs so that we know, without looking at a diagram, where they're going to the write and read decoders, to the mjump logic over on their board, to the ALU EEPROM.
The address lines going, the yellow lines, are the address lines going into the EEPROM. We select what functions they perform, and then these are data lines coming out. We had a problem deciding what selected which EEPROM, either the low or the